Students, go for the next one. Let's do some problems in design of field windings. So before going into the problem, you have to go through all the steps of field winding. Just go through all the thing, and you have to know about all the formulas in the fingertip. Then only it is very easy to solve the problems in design of field winding. Let's go for the content. This is the problem now. Just consider what are the data are given. A field coil of a salient pole alternator with a wounded with a single layer winding with bearer copper strips. It's nothing but a 30 mm deep. So it is nothing but the depth value df is nothing but 30 mm, and it should be converted into meter. Then it is separated insulation of the thickness of 0.15 mm thickness. So insulation thickness is given, it is 0.15 mm. Then you need to find the winding length and number of turns and thickness of the conductor to develop a mmf value is there, which means of 12,000 amps. So the mmf 80 fl full load mmf 12,000 amps. Then a potential difference of 5 volt per coil. EF value is there, 5 volt per coil value. Then with the losses also declared there, it is a dissipation of losses QF, small QF. It is nothing but 1200 watts per meter square. Then the mean length of the turn is there, that means L suffix MTF is nothing but 1.2 meter. Then a resistivity is there, 0.021 ohm per m and mm square. So this all the things we having. By using these things, we need to calculate a few data, which is nothing but height of the field conductor, length of the winding, height of the winding, and number of turns. So it is a repeatably askable one. So just consider to solve. Once again, I repeat this, before going to execute this problem, just study all the procedures in winding design. That means field winding design. Then only this problem is easy to understand. So go with the problem. So for the first one, we're going to solve with the height of the field conductor. This is the formula. HFC is nothing but AF divided by DF. Just check with the data what all the things are in the given data. I think so AF is not there, but DF is there. So you need to find the AF. So AF is nothing but area of the each field conductor. We have a separate formula for that to find that AF is equal to ATFL rho LMTF divided by EF. By refer the given data, all the data are there. So don't worry, substitute all this thing and find the AF and substitute here and find the HFC value. Then the answer should be on 2 mm. So solve and find the content. Go for the next step. Second one, you need to find the number of turns. For finding the number of turns, I'm gather the equations from the field mmf. ATFL is nothing but full load field mmf is equal to IF into TF. For A, I can substitute IF. For T, it is nothing but TF. By using this equation and rearrange this equation because I'm having a TF here. So this is the formula to finding the number of field turns. So here I need a field current value and as well as full load mmf value. So to solve this content, just go for the steps. It is little bit bigger but easy to understand. For the first step, to solve this content, I am going to take a equation of temperature rise. It is in the procedure of 8th step. In that factor, a small QF is there. It is nothing but a capital QF divided by S. A small QF is loss dissipation and capital QF is nothing but loss due to field coil. Then S is nothing but this dissipating surface. By using this thing, we can frame this equation here. By using this equation, I'm going to find the IF value. So reconstruct this equation and I got this content. IF is equal to QF AF S divided by ATFL then rho into LMTF value. So this is the equation for finding the field current for this calculation. So after that, for solving this content, I also have one mismatch data, that S is not there. It is nothing but a dissipating surface. To find the dissipating surface, a formula is there. That is also in the designing steps of 8th one. The temperature rise statement having this equation, S is equal to 2 LMTF into HF plus DF. I think so. Without HF, we have all the data. Substitute all this thing and you got this content and simplify this thing to make this equation. So after simplify this S value, substitute the S value here. Apart from that S value, all other data are in the given data. The loss is there. Then AF is also there. Then AFT is also in the given data. I mean, ATFL is also in the given data. Rho is also in the given data. LMTF is also given data. Substitute all this thing. You got this appearance. Well, substituting this content in substituting this equation to this IF, you got this kind of numerical value. Only this HF as alphabetic. Simplify all this thing and your final equation on this domain. Check on all this content. After that, we can go with the next one. So by using this equation, you're going to find this HF value. So it is nothing but height of the winding. This height of the winding is calculated by TF into HFCN. Here this HFCN is calculated by this content. HFCN is nothing but height occupied by each conductor in a field portion. So for that, HFCN is nothing but height plus 0.15 value. This height value is already calculated on the first step itself. In the first step itself, we finding the height of the each conductor, that HFC. That answer is 2. That is this value, H plus 0.15 is the clearance. By adding this thing, we can easily find the HFCN value. So substitute here and you got this new TF into this numerical. Then with this concern, that substitute this all data to the IF value. So the same thing, this equation is there. Instead of HF, I'm going to substitute TF into 2.15. So TF into 2.15, then into 10 to the power of minus 3 for this meter conversion. Then this 17.14 is there. So simplify this thing and IF will become the last equation on this scenario. Then you can find the IF, then go for the finally first equation. Number of turns, TF, is nothing but the formula ATFL divided by IF. I can find the IF in equation pattern here. So substitute this IF value. Then ATFL is already in the given data. Substitute here and simplify this thing. You got, move all this thing and you got this equation. So make this TF on, substitute this content as an equation. You got this type of equation and reduce this content. You got this pattern. After that, apply a quadratic equation here. You have to simplify by applying a quadratic equation. Then you got a 2 pattern here. TF is equal to 92 or TF equal to minus 1.06. So this is a negative portion. It is not possible, but it is possible. TF will become a 92 of positive term. So take this value as a considerable one. To find the number of turns of the field winding is nothing but TF is equal to 92. This is the answer for the field current. Then a third content, you need to find the height or length of the field winding. So this is nothing but HF. To find the HF, the formula is TF into HFC. So this is a previous content. Here itself you declared HF is equal to TF into HFCN. So HFCN is already declared 2.15. This TF is found out by this equation is nothing but 92. Now substitute all this thing, you got the value that to convert of mm into meter, so it will appear on this thing. So simplify this thing and to find the HF value.